Hello and welcome to the end of year 4 6 skills tests. So children will have these tests in their bags, and ideally they need to make sure that they're getting 7 out of 7 so they're ready for year 5, because these same methods will come up in year 5, but things will get harder and harder as they go. Let's start with number 1, which is just a place value question. The children need to understand that we're just adding one number to these other two numbers to get this final number. And what I always tell the children to do is get the place value columns above them. So they're ones, tens, hundreds, and thousands. So what I'm saying here is that when I've added all three of these numbers together, the number is going to end up with 9,300, 0 tens, and 8 ones. So there are ones, and there are ones, tens, hundreds, and these are thousands. So what I can start to do now, if I change my color, is work out what's missing from this number, because that's what's going to be here. So my ones column, tens column, hundreds, and my thousands are what I'm going to have to fill in here. So in the ones column, my answer has 8, and I've already added this 8 to it. So do I need to add any more ones? Well, no, I don't. So let's change this color and show that there's nothing that needs to be added there. In my tens column, in my answer, there's 0, and I've added no tens here and no tens here. So I'm not going to need to add any more zeros or any more tens at all. In my hundreds column, my answer has 3 hundreds, no hundreds here, but 3 hundreds have already been added. So do I need to add any more hundreds? Well, no, I don't. In my thousands column, I've got 9 thousands is my goal. I've added 2 thousands here, no thousands here. So I just need to think to myself, well, what do I need to add to 2 thousands to get to 9 thousands? Or what do I need to add to 2 to get to 9? And the answer would be 7. So 7,000 is my answer. And the children need to really carefully look at these numbers. And if I add them all together, 7,000 plus 2,300 plus 8, does it come up with to answer 9,308? So if I add them all together, I would see, as I can see down there, 8 add nothing, 0 add 0, 3 add nothing, 7 add 2. I get the right answer. There we go. On to my next question. For a bit of column addition here, I can still understand that these are still my same place value columns as before, and I need to ask myself, if I'm adding the columns in each, if I'm adding the digits in each column, if it goes over 9, I'm going to have to carry some over to the next column to be added later on. So 5 add 5, does it go over 9? Well, yeah, it does, because the answer is 10. So it's the digit on the end that always goes between the big fat lines, and the other one, the one here, gets carried over to be added later on. So 5 add 5 is 10, which is made up of 0 ones and 1 10. Now I've got 8 add nothing, which equals 8, and then I add that one more that I carried from last time, which gives me 9, and I cross that out to show that I've added it. In the hundreds column now, I'm doing 7 add 2. Well, that doesn't go over 9, so I can just put that nice and easily. And then 2 add space. Well, a space is just showing me that there's no hundred, so I could put a 0 there as a placeholder. So 2 add nothing is 2. 2,990. On to question number 3 here. Now I need to ask myself a different question here. I need to ask myself, do I have enough? So let me zoom in a little bit here. Do I have enough to take 8 from 9? So sorry, 9 from 8. I've got 8. Can I take 9 from it? So 8 take away 9, I can't do it. If you show on your fingers, you can't take away 9 from 8. So what I'd have to do is nick some from my next door neighbor. So my next door neighbor's got 30. So I'm going to take one of those 10s, which leaves them with 2 10s instead of 3 10s. I'm going to steal that 10, and then I can subtract that 9 from it really easily. 18 take away 9 gives me 9. 2 take away 9, well, I can't do that one either. So I'm going to have to steal again, but this time 100, but it's still just stealing 1 from the column. So 8 take away 1 is 7, so I've stolen that one. I need to show that I've stolen that one to put it there. Now I've got 12 take away 9. So 12 take away 9 gives me 3. Now I've got 7 take away 7, which is 0. And I've got 2 take away another space, which we said was, there's nothing there, so it'll be 0. 2 take away 0 is 2. Here we have our multiplication question, which is already set up as a column multiplication here. Let me change my number for, change my color, sorry, to work them out. So what they need to do here, I've shown them loads of times, but we multiply every digit on the top by the same digit at the bottom. So we'd do 9 times 7, 9 times 2, 9 times 3. And if the number goes over 9, then we just carry over to the next column, just like we have been doing. So I've shown them a different way as well, like this. So 9 times 7, 9 times 2, and 9 times 3. That's what we need to have done by the end to get this question right. So the first one is 7 times 9, or 9 times 7. If they don't know how to do this, then they can write their 7s down, they can write their 9s down. They can understand that 7 times 10 is 17. You can take away a 7 to get to 63, or they can use the finger method where they put the 7th finger down. They'll show you that one. So 63, 3 goes in the under the column we're working in, because that's the digit on the end, and the 6 gets carried over to be added later on. Then we do 9 times 2, which is 18, plus my 6 there. You can count them on your fingers, just that 2 and a 4, either one. So 9 times 2 is 18, plus 6 is 24. So a 4 here and a 2 here. Cross the 6 out to show we've added it. And then 9 times 3 is 27, plus 2 more is 29. On to our division question now. This would look like this in a normal question before it's been set out. 363 divided by 3. What we're asking here is what number would I have if I divided 363 by 3 people, or how many 3's go into 363? Usually with these questions, I'd ask them to write out a list of their 3's so they can count in them just once and not keep having to count in them. But this one is a really easy question that isn't really indicative of what we've been learning in year 4. So I put a more difficult question as number 7, which we'll go over a bit more detail. Here though, 3's into 3 goes once, 3's into 6 goes twice, 3's into 3 goes once. We have a really easy fraction question here. The deep down denominator stays the same because all that's asking is how many parts is the whole split up into. So the deep down denominator never changes when adding or subtracting, especially when the denominator is the same. So all we need to do then is add the 2 numerators, which is how many parts we do have. 4 add 3 is 7. Some children might realize that 5/5 equals a whole. So they may have written their answer as 1 whole, and which takes away 5/5 and 2/5. So 1 and 2/5 would be our answer there. Now, this one is the one that I added, which is showing what the children have actually learned in year 4, the more trickier questions. Now, they won't actually do 4 digits until year 5, but it's the same method, so this should prepare them well. So for this one, I would definitely start with writing a list of 4's. So I'll get those in here. So we've got 4, 8, 12, so on. If the children don't know these, then they just need to use their fingers and have little checkpoints or rests to make sure that they're not miscounting. Because if any of these are wrong, then they don't end up working. I'm going to stop at 28, but I can add to it if I need to. So here I'm asking how many 4's go into each digit. So how many times does 4 go into 7? Now you'll see in my list down there, it doesn't go in exactly. So what I tell the children to do is draw a line where 7 would be. Well, 7 would be between 4 and 8, and that would be where 7 is. So it's the multiple above where that line would be. So 4 fits into 7 once, and there's some left over because it's not gone in exactly. So I tell the children to count from the 4 to their goal of 7. So that means that there's 3 left over. So the 3 is what's carried over to the next digit to make a 32 instead of a 2. I'm asking how many times does 4 go into 32? Well, now I don't have that in my list, so I just need to add that on to the end. 32, and I can keep doing that if I need any more. So now 32 is in my list of 4s, so that goes in this amount of times, and we just need to count. 1, 2, 3, 4, 5, 6, 7, 8. So that goes in 8 times. And then I'm asking how many 4s go into 5. Well, it's the same as earlier on, so let me rub some of this one out. Whereas 4 goes in, it goes in once, because 5 would appear here. That's where 5 would be, between 4 and 8. So circle the multiple above that line, so it's gone in once. How many is left over from 4 to get to 5? Well, there's 1 left over, so that gets carried. And then I've got 4s into 16 to finish there, and here it is, nice and easy in my list. 1, 2, 3, 4. So it goes in 4 times. And if it doesn't go into that last number exactly, then I just show what's left over with a remainder. But this one doesn't need it. Thank you very much for your support. I hope your children will use these over the summer holidays to make sure they're as ready as possible for year 5. Have a nice evening. Bye.